Hey, this is the last video, last video of this lecture. So the p-value, when you have t-statistic 1.5, what is the p-value? Remember, we are doing an upper tail test. We are looking only at the upper tail, whether it is greater than 0.8 or not. So p-value must be calculated on the upper tail, only on the upper tail. So your p-value is this guy. Z greater than 1.5, that's it. So you do not add the negative side probability. So it is 6.6%. And 6.6% p-value is greater than the significance level, 5%. So it is not rejected. So even if you observe 86%, it is not statistically significant. And your belief that Affordable Care Act does not increase the coverage rate is not rejected. That's the result. If it was a two-tail test, the p-value would be doubled, and then it's even less likely to be rejected, right? And now T-Statistic Approach, we calculated T-stat, and now remember, rejection happens when T-statistic is too large, only on the upper tail. So and alpha, the whole significance level alpha is put on the upper tail. So you have to take Z alpha, which is 1.64, and your T statistic is not greater than this. So H0 is not rejected again, right? So if only when T statistic is greater than 1.64, then you admit the positive effect of the Affordable Care Act. Then how about the critical value? In this critical value, how can you calculate the critical value in this case? 3, 2, 1. So first, you have to remember that the standard deviation was 0.4. So your standard deviation is coming from the null hypothesis, and the null hypothesis implies 0.4, standard deviation 0.4, and then let me just go here. So your standard deviation is on the upper tail. Also, you have to remember the direction. So you have to think that H0 is rejected if the sample mean is too large. So your direction inequality should write this way, and you have to add, not subtract, add a margin of error. The margin of error uses the alpha, which is 1.64, and standard deviation 0.4, sample size 100, and of course mu 0 is 0.8. When you calculate that, if you plug in the numbers, you get 86.56%. So you are very strict. Only when the coverage rate increases above 86.56%, you admit the positive effect of the Affordable Care Act. And again, H0 is not rejected, which is obvious because we did not reject H0 in the previous methods. So the critical value should not reject H0 either. Okay, we practiced p-value approach, t-statistic approach, and critical value approach. Idea is the same. It's quite simple. Calculation is quite simple. Just simple application of the formula. But what can be confusing is the direction. But also it's intuitive. If you think about what we are doing in this example, then it is quite straightforward, I believe. And the next exercise is type 2 error probability. Now, then how we would like to calculate type 2 error. In this case, type 2 error is that the Affordable Care Act had a positive effect. It was good. It did improve the coverage rate, but you could not see that. By random error, you fail to see the positive effect. Now, what is that probability? Now let's assume that the truth was actually 90%. So actually the Affordable Care Act increased the coverage rate to 90%. Then what would be the probability of still you do not observe significant increase? Type 2 error probability, try to calculate the type. What is the probability you need? The answer here is 3, 2, 1. Here the answer is you don't need any standardization. I'm just asking you how you set up the equation. Here remember, type 2 error is the probability of the error that you do not reject a wrong null hypothesis. It happens when you do not reject. So you do not you remember you reject when x bar is greater than this. So this is the rejection condition. So you don't reject in this case. This probability is type 2 error probability. Of course, you have to condition this on 0.9. But I omitted that. But anyhow, the point here is you are calculating the probability of not rejecting a null hypothesis. That's when you can make a type 2 error. So, and another tricky thing here is, so now you set up the probability. You know the probability goes like this. Then how can you standardize it? How can you standardize it? Try standardization. 3, 2, 1. The answer is, let's look at this. So first, you have to subtract the mean and the standard error. The mean is coming from the truth you assumed. You assumed that the truth was actually 90%. So you have to put that in the mean. That's easy. But the standard deviation is also coming from the assumed mean. So 0.9 implies 0.3, or standard deviation of 0.3. So use the 0.3 as the standard deviation in this case, right? And then it's easy, and you will get 12.507%. So even if the probability increases to the coverage rate increased to 90% after the policy change, still you may not be able to see the change with 12.5%, right? On the other hand, the power is about 87.5%. So power is the probability of you actually observe the change. Okay, this is it. It's the end of chapter 10. And I'm going to post the homework and walk through for the homework. And I will come back with chapter 11. Have a great weekend. See you later.